Today we're going to talk about a paper from Facebook. I just simplified the name. It's using a longer name than this. Basically, the paper is talking about the managed data store locality at scale with the Akkio. Akkio is the product name or service name they picked. So this is based on the paper. Let me see if I can get the paper info. Oh, anyway, so this paper was published around 2018, so 3 years ago. So everything I talk about today is based on my understanding from this paper. It doesn't mean Facebook is still doing that today, or so a lot of details they provided, I just translate into my understanding. So, okay, so let me move on. So let's first think about one question. So why does Facebook need Akkio? This is also the paper spent a lot of time talking about the requirements, the use case, and the problem they're trying to solve. They spent like 2 or 3 pages talking about this. So I would introduce a little bit more about the problem, and we see how Facebook solved the problem by using Akkio. The first question: why does Facebook need Akkio? This is a screenshot I took from the Facebook blog. This is typically a application stack used within Facebook even today. So just like simplified a lot of components. We have a client-side user, and we have load balancer in between the stateless web servers. In the end, we have the data storage system. It could be replicated and it could be sharded. So all the data are like that. So this is typically the application stack. So the problem from Facebook research was, since the amount of user are growing, keep growing. So we have a lot of data as well. So what happened is, within Facebook is like, we have the users around the globe, right? So every region, every places we have the user to access the Facebook service, your mobile application, your homepage, the web browser homepage. This is the first point I want to point out is, from the Facebook research, they found that they have a lot of users around the globe, and also they have the data distributed, because they have a large amount of user data. We cannot fit every data into one place. So typically within Facebook, the data is like replicated and also sharded. So sharding is pretty straightforward way to think about that. We have a large amount of data we cannot fit into the one node, even like, let's say, one server, right? So we have to cut the data off to different smaller chunks, and we need to move the data, right, to different servers to better serving the user. Having one sharded data is not a good way, because even like if the server is crashed and that data is getting lost, right? So usually within Facebook, with even like other like applications, social network service, they're going to replicate the data as well. So with the point 1 is we have a lot of users, and point 2 is we have a lot of distributed data around the globe, right? So another thing from Facebook experience was, we have a lot of data distributed, and we have a lot of users from different angles of the world trying to access the data. And they try to make sure the application, the service users are using with low access latency. So what does that mean is, like, you open the mobile app and you want to see your friends, the news feeds, right? So you want it to be as fast as possible to display it on your homepage, right? In your mobile phone, right? So we have 3 points here, right? Actually 3 points, yeah. Large amount of a larger amount of clients around the globe, and we have distributed storage with larger amount of data as well. And the third point is like low access latency. Right. So this is basically from the Facebook's experience. They try to make sure every application can meet those requirements, right? So this is basically the first part of the paper is talking about. And based on that, let's see the problems, right? So in the case of Facebook, we just mentioned about the replicated data, right? So we want to make sure the data cannot get lost, right? So we replicated data for fault tolerance. The first question come in, and what is the replica factor we should choose, right? So usually if everybody is familiar with the distributed consensus, we choose 3 or 5, so this kind of number, right? So within Facebook, so do we want to choose 3 or 5 or even bigger number, right? So this is the first question coming to Facebook. So we have like a trade-offs between the replica factor. So the larger number you choose, which means you are going to copy more data around the globe, right? So you need to have like 3 copies, 5 copies, even more copies, which means your data migration overhead is pretty high, right? So if you choose lower number, right, like 1, right, so it doesn't meet the requirement for fault tolerance, right? So this is the one thing, the one problem that's facing. Sorry. So another one is, so even we have this problem solved, so the next problem is we want to keep the data closer to the clients for data locality, right? So this is one requirement I just mentioned from the 2 slides before, based on the Facebook paper. But the thing is, it's really hard. So one thing is the data access pattern is dynamic, right? So for example, we have a very hot topic happens today in US, and a lot of users from US will access that data. So it's okay, we put the data in the US West Coast or East Coast, different regions, so for better serving users. But what happens tomorrow or even next month if this topic becomes hot in Europe, right? European users will try to access the data. So do they still try to do we still want the user to access the data in US regions? It's like cross the Atlantic Ocean or Pacific Ocean, right? So this is hard. It is hard because we don't know the access pattern. So it's really hard decision to put the data, right? So even you put the data today in US West region, right? Tomorrow the access pattern changed. So what are you going to do, right? So in order to make the data closer to clients, we have a caching, right? So caching is I would say the most important layer within Facebook to support one of the use cases that support the data locality, right? So we had several talks around this caching from Handling and other folks as well. So we knew that caching layer to fit all the requirements is complicated. So the reason is why it is complicated because we have different, for example, like consistency requirements, right? We have strong consistency or like relatively not that strong consistency, right? So we cannot have a very generic solution to hit all the cases, right? So this is really, really complicated, right? The third one is they try to, so as I just mentioned, so the data is pretty big, like a giant table, right? We have a big table, we want to shard it, but the shard is today, like sharding today solution we're using data store like Redis or whatever, the data store, the data assigned to a shard is decided by the data store. So you provide either provided the sharding key or even a range of the sharding key, right? So we just provide some roughly basic information so about which kind of data want to go to which shard. But the problem is actually where that shard is located. So we have like, let's say we have a data store with 3 nodes. So 1 node in US West, and 1 node in US East, and 1 node in Europe. Right. So even we have a knowledge to assign application data to a shard, but where this shard should be located, US East, US West, or Europe, right? So this is not decided by the application itself, right? So this is a really pain point for in the case of Facebook, right? Because I would say not all, maybe most of the infra layer from Facebook is built to better serving the application, right? So this is the one pain point. Another pain point is like they want sharded data, and typically from the data is from the paper, right? So they said a shard usually holds about 10 gigabytes of data, right? And we have like tens to 100s, several hundreds of shards are assigned to a node. So this number is from the paper. So behind this, Facebook means, right? Because each shard is pretty large, right? If we want to move the data around the globe to make sure the data locality, right? So this overhead is pretty not the same we want to do within Facebook, right? So they try to find a solution for all of these problems, right? So this is why the paper comes out and the Akkio was introduced, right? So this is the problem and why the Facebook want to have a solution like Akkio to address those.
Can I? Sorry to interrupt.
Yep.
Can I ask one question? Oh, maybe maybe I will just add some more context for Akkio, like compared to the cache solution. Can you go back to slide 5? Yeah. So I think as you mentioned that the caching is complicated. I think that's true, and I think one of the most fundamental reason why Facebook chose to implement another system called Akkio instead of using their caching system. I know like they're facing the consistency issues, they're facing the locality issues, but one of the biggest issue they are facing is the read-write ratio. So I think Alan mentioned like maybe previously he has saw some workshop video from Facebook that if Facebook implemented maybe 2 type of system. One is for one is where some system with very aggressive caching policies, and the other is for write-heavy system. So Akkio is designed for this write-heavy applications. And something like, so they raised some examples like something, probably you mentioned something called the view states later. So it's something like every read will cost something like a single write. So that means caching will not be effective in this situation. So something like every time you're updating the data. So yeah, if you don't have a very high read-write ratio, then caching is not be effective. So I think that's something I want to add to this, the problems they are facing. Yeah.
Yeah, thanks for adding this. Actually, I forgot to mention this point. It's one of the reasons they choose their problem with the caching solution. As Henning just mentioned, this read-write ratio is for the application, the solution trying to solve is to serve the the application who has relatively low read and write ratio, it doesn't mean the number is less than 1, right? So it could be, so as what I mean about high read and write ratio is like you have like 1 million against maybe 500. This is a pretty high read-write ratio, right? So for lower ratio, I probably mean like 0.5 million against the 1,000 or 100, 10,000. So this is, it doesn't necessarily mean the read ratio is less than 0. Okay. So thanks, handling. Actually, they have 2 points to add. I forgot to mention it earlier about the caching is complicated part. So even like the Facebook paper mentioned 2 things. One is the cache miss, right? So based on this assumption, read write ratio, how about the cache miss? So even we have had cache miss, right? So that means that the access need to be redirected to the database, right? So it's quite important where your data is located, right? So if your data is far away from the cache layer, right, that means probably you have higher latency, right? So this is about read and the cache miss on read, right? So we probably cross the region to access the data. Yeah, I'm not going to deep dive into the how Facebook solved the cache miss solution, but this is one just adding some other points. So another one is about like the data write, like for the cache layer, right? So the thing is like still the problem from remote data store access, right? So if we want to write a data, right, even we use write through cache, right? For example, we use write through cache. We still try to write data into the data store, right? So this arrow here means you still need to somehow talk to data store, and it's quite important as well where your data store is, right? So this is just 2 points I missed earlier, and thanks, Henning. Any other questions? Okay, let's move on. So let's take a look. What does Akkio do? So I summarized 4 points here. So the first one is Akkio defined a concept of, they call it microshard. So at this point, you can think of it just like a very smaller size of a shard. Actually, it is a shard, but it's a microshard in terms of the size, right? So you can think of this right now, but it's more than just the size differences, right? I'll talk about that later. Right, so this one, what they try to do with this concept is, remember, in these slides, we talk about the pain point number 3, right? We got tens of gigabytes of data per shard assigned by data store, right? So the whole overhead of migration is pretty high. So the easiest way just to make the shard smaller, right? So this is the first thought came into the mind, probably into the mind of the designer, but this is the first thing I thought of when I read the paper. Another one is about the track. What Akkio does, it tracks client application data access pattern, right? So the number 2 points is mapping to this pain point, right? So we want to keep the data closer to clients for data locality, and this data access pattern is dynamic, right? So we need something can track the data access pattern. So we have some knowledge about the data access pattern, so we can move the data around the globe to guarantee the data locality, right? So this is the second thing Akkio does, right? So the third thing is it decides when and where to migrate the microshard for locality. So for example, we have the data access pattern pretty dynamic, but it doesn't mean, right? Let me put it this way. I have a data store located in the US West. Right, today it's pretty hot topic, and people from US access to the data, right? So tomorrow probably the data access pattern shifted to European, right? So it doesn't mean we are going to migrate the data to the European data center right away. So there is some mechanism we need to do some calculation, right? So we want to based on the access pattern for a given period of time. So we don't want to move data. Maybe today I move data to European, and tomorrow I move data from European back to US. So we don't want to do that. So the third thing they want to try to is they want to find a smarter way to decide when and where to migrate the microshard for locality. So the fourth point is this is pretty straightforward because we are moving the data around the globe for locality, right? So we need to somehow let the application know where to access your data, right? So this is pretty straightforward. So I summarized 4 points, and this is just give you some high level ideas on what it does. And from the following slides, we're going to deep dive into that for each part. Okay, so this is just a screenshot I took from the paper, just to give you guys some high level sense on what did I mean about these 4. So from this screenshot, we have ABC 3 data centers, right? A, B, C, and then within each data centers, we have like different colored boxes. So those boxes are representing a shard, right? A shard and replicated shard, I would say. So this is the shard number 2, replica 1, and this is the replica 2, and this is the prime. So the so from this diagram we can see like it doesn't that straightforward, but you can see that we have a primary, we have replica. So basically you can guess it's based on the replication is based on the leader based consensus, right? So what does the Akkio do is, let's say we have a data center C with sharded data, let's see, ID is 78, which is a primary, so which is holding the write access, right? So I have a small box X here. So this means this data today is pretty hot topic. Let's say I'll make an example. In the data center C, so which means we have more and more data, more user access the data X from data center C, which are closer to data center C, right? So what happens like tomorrow, maybe next month? So the access pattern changed. So we found more and more users from which are closer to data center A are actually trying to access the data X, right? So at this point, so what Akkio does is it will migrate the data from data center C to data center A. So this is this arrow means the migrate. So this is actually done by Akkio, and because as I just mentioned earlier, the data needs to be written to the primary first, because the replication is the leader based. We write to the primary one primary, right, X here, and the under layer data store, it's their responsibility to have your data replicated. So those are dot line arrow here and there. So this is pretty high level. Just have a very basic sense of how data migration means in this paper and how the micro shard means in this paper.
Is the data, sorry, in shard 78, is that micro shard removed from 78? Or
Removed? Do you mean you mean removed?
yeah, is it removed from 78 and then written into shard 1, or the X still stays in 78?
It will be removed eventually because the migration happens as I just want to move this data from this place to that place, which means eventually this X will be removed once the migration is done, right?
Okay, I see. Thank you.
Yep.
One question. So is this something like originally on 78, the micro shard X is holding the primary replica, and then the primary replica row is being shifted to the replica 1 in the A data center. Is it something like this? Is this the migration? Like making the micro shard X in A being the primary replica instead of the one below in 78.
You mean this one?
The one below in the gray box in C. Yeah. So originally, this one is the primary, right?
Yeah, this is the primary. So all the data writing will be redirected to the primary. Like let's say we have we have how many colors we have? Like 4 colors, right? 4 colors means we have like 4 shards, right? Four shards of data, and each color has replicas, and there will be only one is primary. So all the data writing is only redirect to the primary. So that's why this arrow just between 1 primary and the 78 primary.
I see. So I mean, take the example, for example, you can see typically in the box there is X replica and sorry, X shard, micro shard, and there's a 2 micro shard. So I'm thinking it's something like when we are doing the migration for a micro shard, so it's only the targeted micro shard changes its primary location. The others are not being infected. Is that correct? So it's not like a migrating X and 2 at the same time.
In general, I would say yes. Yeah, we'll have we have deep dive into the migration path later on from the following slides, and we probably could discuss a little bit more
okay,
later
sure.
on. Does that sound good?
Yeah, sure.
Okay. Let me move on. Sorry, is this a typo? Anyway, Akkio Architecture. So we knew what problem is. We knew what Akkio basically high level what it does, and now let's take a look at Akkio Architecture. Okay. This is the again the screenshot I took from the paper. So I added some red boxes here. So this is just something from my understanding. So I will just cover them one by one. Okay, so for Akkio, it basically is a middleware I would say, middle layer between the application, let's say view state service, and the view state database, data store, right? So they are using ZPDB internally. So this is the Akkio system is really just something in between. The application tries to access the data. So it will talk to Akkio first, right? It talk to Akkio first, and then get the location. And then after that, I would access data to the data store, right? So for migration, what happens is like Akkio initiated the migration, and data got moved, right? So got moved, and the location changed, right? Next time application tried to access the data, again, it will ask Akkio where the data is, and then go ahead to access that. So this is very, very high level. Don't worry, I will keep this diagram and talk a little bit more, deep dive into that. Before moving forward, I want to highlight one thing I learned from the paper itself. So based on this design architecture for Akkio itself, it has some requirements for application and data store. So as you can see here in this box on the top, the reason is because the application service need to talk to Akkio. So there should have an interface, right? So there need to some way you can integrate a visual application and let it talk to the Akkio, right? So what they use is the client library. So one thing I truly don't really agree is they embedded the client library into the database client library. So I'm not sure if they are still doing this today, but based on this design, so this is the one point I really don't truly understand why they are doing that. So yeah,
sorry,
go ahead.
Sorry to interrupt. I think that makes Akkio opaque to build state service, right? So for everyone who's using the ZPDB database, they'll just use the client library, do everything they want as usual. But with the built-in logic of Akkio, this ZPDB supports Akkio, implicitly, so that view state service is actually agnostic of the existing Akkio, still benefit from the service itself by having, for example, lower latency or something like that.
Yeah, so this is exactly true, but yeah, I'm thinking, actually I was thinking the other way is like what happens tomorrow I'm using different database and embedding to different database, especially the ZPDB is from Facebook internally, so they can easily change the code and embed it the client. So what happens tomorrow I'm using other outside commercial product, maybe, I don't know. But this problem got solved from Facebook, guys. Thanks, Alan. I think Alan pointed us a engineering blog from Facebook last week about the shard manager. So yeah, I'll point this out later on from the following slides. Yeah, so talking about the requirements, I just mentioned Akkio has some requirements for application, right? So the number one is this interface, right? So number two is the data, which data is assigned to a shard, a micro shard, is decided by the application, right? So it's the application's responsibility to partition the data into micro shard. So this is a very basic, simple idea why they designed this. They want to let the application have a way to assign the data to a shard, because the application has a better knowledge about which data is more related to another one, right? So this is the second 2 point requirements from to the application layer. So another one is the identity, right? So identity of the microshard, because all the microshards, we have to track it, right? So the identity of a microshard is decided by the application. So actually the application is going to have, put it simple ways, like application need to generate a microshard ID, and that microshard ID is not auto-generated by Akkio, right? So let's say we have if we shard the data based on the microshard ID, so they have to figure out a way how to generate a very good ID. You can shard the data as you desired, right? So this is for application. And another requirement from Akkio is to the data layer, data storage layer, right? So because they have the idea of a microshard, so they do not want the microshard to, like, across two shards. The database has their own definition of the shards, right? So we have two concepts here. So one is the microshard. So let me see if I can find a very good diagram. Okay, let me get back to this. So let's say we have a microshard X, right? So this big gray box is traditional data store shard definition, right? X is the microshard concept from Facebook, right? So the requirement is we do not want this box X cross two shards, cross two data store shards. Let's say the green one and the gray one. So we don't want the X sitting between these two, right? So this is one requirement Akkio needs from the data store layer. Okay, another requirement is, because we are doing the data migration, right, to guarantee the data locality, it does not actually automatically so let me put it this way. So Akkio need to talk to the database to migrate the data. Actually, this line is here. Like I just, for example, Akkio is just the person to tell the data store, I want to delete a data from like node 1. I create another same copy to node 3. So this is just some like notification API invocation, right, to the database, right? So actually the data movement is done by the data store, right? So this, we have some like requirements for the data store to make sure like the data consistency during the migration can be guaranteed, right? So we don't, let's say we want to move the data from this node, we have 3 here, right? From this node to another node. So during the migration period, I do not want data to be inconsistent or lost or whatever. So this is another requirement from Akkio against the data store layer. Okay, so we got very high level picture here. So next I'll go to talk each component one by one, so we can have a better understanding on how data get accessed and how data get migrated. So the first one I'm going to talk about is Akkio location service. Yeah, actually this is the requirements I just mentioned. I forgot to move the slides. Okay, so yeah, I'll just keep this screenshot here for reference. The first one, location services. It is the left bottom corner component, Akkio location DB. So actually, it's not just a DB. It's actually they call it the service, right? So also I summarized 4 points here. So what Akkio does. So the location service is deployed in each data center. right? So it's not a like deployed per node or per server. It's like data center level service. So each data center will have one. Okay, so let's make it a more visual. We have 3 data centers here, A, B, C. So on each data center, I will have one location service. So the second one is the location service is tracking micro shard locations. So from the name, we can tell this this characteristic, right? Because for application, we want to know where the data is located, so we can just ask Akkio and give me the location. I go to access that. So for migration, right, once the data got migrated up, the location is updated. So we also need to track the location here in this location database. It's only for the location related request and response. Okay, so as we see from the diagram, they're using a data store, right? Actually, internally, if it's from the paper, it says Facebook is actually using their own solution, ZPDB. This is for data persistence, right? We don't want the data location data to be lost. So the last point here is it's not in the diagram, but it's maybe 1 sentence or 2 sentences from the paper. It says actually Akkio location service is using the cache layer to cache the location information. It will be between the application service and the data location DBs somewhere here in between. Okay. So next is like we have a question, right? So one question I came up when I read the paper is why the location DB is data center level service, right? So it's also describing in the paper. So what the paper said is because the total amount of data to be stored is relatively small, right? So from the paper, they said, if I recall, the number was several hundred gigabytes of the location data per data center. So it can easily handle the data center level services, right? So if the number is true, like several hundred gigabytes, it's not a big deal. Okay, so this is this is one question I came up and got answered in the paper. So just want to highlight it here.
Okay, I think another reason might be they want to minimize the latency, because the whole point of Akkio is to minimize the latency for client application, right? If you want to do that and you're asking the client library to make requests to another data center, that just doesn't make sense, I think. So they have to have this service in every data center. That's just my understanding.
Yeah, that's true. That's true. It's really the trade-offs, right? So if we want to put this location service one layer upper, like regional services, right? So there will be some like cross data center access. Since they mentioned they are also using like a cache, right? So if we have very strong and very good caching layer, probably that latency issue could be solved, but I don't know. It's not mentioned in the paper. So yeah, this is just a very open topic. We could have a deeper discussion in the end if you have time.
One thing they need to mention is just the access to Akkio location service is on the critical path for the user request. So every user request, they need to first get the location of the micro replica or something similar in the request. Then they can fetch the data from the real data store, something like that. So yeah, so this is the latency is a pretty important issue for users. And also, yeah, they mentioned that they are using a caching system in this system. I think that's also for latency improvements. And the caching will cause some consistency issues because it has a pretty weak consistency model. It's using read or write. And if the consistency, they got a consistency miss, or for example, the ALS returns something like you can fetch the micro shard from this data store, but actually they cannot find it in that data store because it's migrated to some other place. Then the client will do a retry, and in that retry they will embed something like this time I want you to bypass the data store, just access the ALS data store DB without the cache, and they will do that for that can solve the consistency issue. Yeah, that's some amendments in the paper.
Yep, exactly. Okay, let's move on. So for location service, we'll be talking about how the data got read. Actually, it's not data got read, it's like how the read access is served by location service, and followed by that, we'll be talking about the write. Okay, so for read, basically just query, right? So we want to get the location data. Location data is fine. Yeah, we're gonna get a location data of a particular micro shard, right? So then the client side can use the location to access the data in the real data store. So this is about read, and basically we have 3 steps right here. So the first thing happens is the Akkio library, client library has an API, right? So this guy, Akkio client library, it implements some logic behind the API, but exposed to the upper layer caller, right? So what it does is like your application try to access the data and then passing the microshard ID, right? So why the microshard ID? Because as I mentioned few slides before, the assignment of the microshard ID is done by the application itself, right? So it knows the data, right? So I'm passing the microshard ID to the API, and the API call will return a bunch of locations, right? So the bunch of locations means because the data microshard actually is replicated, so there'll be more than 1 locations, right? And after that is a call to the data store to access the data, right? So this is very high level steps. So what happens on read? In this diagram, let me zoom in a little bit. Here, right? So we have the get location API exposed to the upper layer caller, and we call it by passing the microshard ID. And this call goes into the location service, right? So this, if we have like cache heat, then we just return a cache means we read into, we redirected reads into the location database, right? So this database is basically also like tracking the microshard and locations, right? So in the paper, it mentions some concept about the location handler, right? So this location handler that is slightly different in different underlayer data store system, right? So in the case of the ZPDB, right? So they are interpreting the location handler as trying to recall what they called replica set collection. So we cover that later, but let's just trying to like think this is just the location, the identity ID of your location, right? The microshard location. So this is what happens on read when application trying to access the data. And next one.
So just one more question. I'm just wondering, like when you talk about the user ID, like how does the application actually know those ID in the first step?
In the first one, how the application generates the
exactly.
like, okay, so I remember in the paper they talks about let's say let me put it this way. Let's say we are using the white column database, for example.
We
like
have Cassandra or DynamoDB, something like that.
Yeah, let's say we have, I would say, ID as the first column, right? And then we have another key. Maybe this is some like for sorting, right? For sort purposes. So maybe we have other thing. So application, for example, we have this one is for like view state surveys. I have a 1, 2, 3 as the ID. Right, I have like another keys. I'll put it this way, relevance. Okay, so relevance key means I can use the same key for the data which is like more related to each other. So let's say we have this one as 1, just for example. This is for a view state service, right? So this ID could mean anything. It could be from different user or whatever. This is just an identity. So if we have another one here, 4, 2, 3. Actually, the paper doesn't mention any details about how they generate the microshard ID. This is just from my understanding. So you can have a
that's how we can deep dive in later. Because I'm confusing, like if you got multiple applications, it would be so hard to know to like avoid those conflicts. Like say multiple like application, they got same kind of like a user ID. So which means like you have to introduce in some other system to do the handling thing. Yeah.
Yeah, I read about this in the paper. Actually, they mentioned something about the by using 2 keys to locate which data belongs to which microshard. And let's say I can use 1, 2, 3, 1 as I could use 2 columns, actually use it for the microshard ID generation, right? So 1, 2, 3, 1 in this case, probably 1, 2, 7, 7, 1. They are sharing the same. Yeah, in this way I put it 1 as the suffix, but if I put 1 as the prefix within my microshard ID, I could easily put these 2 data, 777 and 1, 2, 3, into the same microshard.
Right, but anyway, so you're thinking the logic is actually like a stay in the application layer, is that right? How actually build up the key for the user ID.
That part for how the data for how that part is persistent, I don't remember the paper mentioned that.
Oh, that's fine. Like maybe let's just assume there's like some way they can create like generate a user ID. That's fine. Like let's move on.
Okay, sounds good. Where we are, let me remove this. And next one is about the write. Write basically means the update, right? So what happens? Who will update the location service DB is they call it Akkio data placement service, right? So once the data is migrated from one place to another location, so this guy need to update the location database, right? So as in the paper, it mentioned the DPS actually is update the microshard records during the migration. Yeah, so this is very simple. It's simplified. It's just a summary. Actually, it updates. It has a lot of details. With when we talk about the migration, I will mention it again. This is how the location service handle writes. Yeah, this is the location service component. Do we have any questions so far? I see there is one thing from the chat. Yeah, I think the question Fan Yuan had is the same one as Alan asked about the microshard ID, right? So let's have a discussion later on. Okay, so the next component is the called access counter service. So which is the component in the middle, the Akkio access DB. So what it does is, so again, the 4 points, 5 points. The first one, the same, it is also a data center level service to serving all the requests from the same data center, right? So the second point is it tracks the access pattern, right? So the second point and third points, what it mentioned was in the paper was it tracks the access pattern where the microshards are accessed from. So if we go back to this diagram, right? So today we have more user access the data X from data center C, and tomorrow if we have more user access the data X from data center A. So basically this access pattern is tracked by the DPS, data placement service. Okay, this is also the same thing. It tracks how frequent the microshard are accessed. So all these things are needed when the data placement service to make a decision whether the data is still the current placement is still optimal or it's suboptimal. I'm going to migrate data or not. So these components. So I store those informations mainly for serving the DPS. Okay. So the first point, single counter per microshard per app per data center. Yeah, this is also one point mentioned in the paper is like, because I want to track the access pattern, right? How frequent I'm using the counter, and this counter, I only have one counter for one microshard for one application from this data center. So put it straight is, I have one counter for in the previous diagram we have like a small box X, right? For one counter for the small box X for this view state application within the data center C, right? So let me go back here again, right? One counter for this guy, and for that particular application from this guy, from data center C. So if we have data, if we have microshard in different data center, for example, we migrated data from data center C to data center A here, I will have the same counter here, right? Within the data center A, I will have another counter here in the data center B, right? For these two, because these two X box, they are the same. They are the same microshard, but different replicated data. Okay, so hope this makes sense. Let me get back. Okay, here. The last point is based on my understanding from the paper. Actually, it doesn't. The paper doesn't say so. So what I mean was, the multiple application service share the same counter. Yeah, actually, this does mention in the paper is about the improvement of this access counter service, because, for example, we're using one counter per shard per application, and if we have so many applications and so many shards, what happens if we have like so many counters, right? So this point actually is mentioned in the paper. So the how they can reuse or two application to share the same counter. So two similar application who has the same similar the data schema, so they could use the same counter. You can save some places, right? So this is a 5 points mentioned in the paper about the access counter service. So next one, let's talk about what happens on write. So this guy. So we can see from the diagram, we can see there are like two arrows. One is query and one is access, right? So the write is actually this path. So the write means update, right? So I want to update the database only the arrow from the client application side, right? So the application is the one to access the data, right? So every single time the application accesses the data, so let's say I got the location, I go ahead to access the data, and I will call the access service, DB service, to update the access pattern for me. So one thing I want to mention, point out is this is a synchronized call, so which means that the application does not wait the response from the access DB to proceed to next operation. So this is a sync call. It makes sense, right? Because we want to provide high level, not high level, low performance, low latency. I would say a low latency access, high access rate. So we don't want to wait and block here. Okay, so let's see how each steps does. So the first thing is like the client talks to the access counter service on each access of the microshard of the records. So as I mentioned, every time the application access to the database, and it needs to call asynchronously to update the access DB. So here, it's just 2 or 3 sentences mentioned in the paper is that this counter is time window based, right? So let's say we are tracking the access pattern frequency per day or every 4 hours or every 10 hours. It's time window based. So let's take an example from I want to track the access pattern for daily basis, right? So today I have a 1 million access frequency counter. Tomorrow I will start from 0 and keep going. So this is the window, time window based. Okay. This for next one. Let's see what happens on read. Read is this path, the query path. So in the Akkio system design, so the DPS, Akkio DPS data placement service is the only one to query the access DB. The reason is that because it needs to know the access pattern, and based on the access pattern, and to make some decisions whether I should migrate the data or not. Yeah, this is the one query. So we will talk a little bit more about when we, from the following slides, and when we talk about the DPS. Okay, next one is the data placement service, which is the brain of the entire Akkio system, I would say. It's a pretty core component. Again, so I summarized some points from based on the paper, and the first one I want to mention is the DBS is also a data center level service, and it's deployed per data store system, right? So which means if from this diagram, right? So let's assume we are visiting the data center A, right? So within data center A, we are using ZPDB as a data store layer for view state service application. I will have one instance, right? One instance per backend data store system and in each data center, right? So if we have another set of the data store layer, let's say we are using like MySQL, right? MySQL is serving the same service. Let's assume that way. So I will have another DPS service instance for that. So that is because the migrate is really like depends on the implementation of the data store layer, right? So I want each one for each data storage system. Okay, so the next one is mapping the microshard to location handle. Location handle is just the location ID, if you can, yeah, for better understanding, right? So in the location database, we are mapping the microshard to the location, right? So it does not done by the location DB automatically. Actually, it's done by the DPS data placement service. That's the only one who knows where the data should be located. So it maps the microshard to the location handle, right? So I move data from one place to another place. I know where data is, so actually I'm mapping it together, right? So it doesn't persist the location database because it just designed which one maps to which, right? And update that data in the location database, right? So the third thing it does, the DPS does is migrate microshard from one data center to another data center. So I want to point out this here is like in the Facebook concept, because the paper is based on the ZPDB implementation. So they are using different concept. They call it like replica set collection, right? So they set the DPS actually migrating the data in between the replica set collection. Yeah, I'll talk about this later. But high level, I just move the data from one data center to another to move it closer to the user. So there are two APIs from DPS. So one is the create microshard API, right? So this is the API will be called when the new microshard need to be created, right? So let's think migration in a simple way is actually I'm just create a new one in a new place and delete the old one. So we need to actually this API, create microshard API to indicate let the data store system know I want to create a new microshard. So this one, delete microshard API actually is not mentioned in the paper. I put a star here, but it does mention in some other engineering blog. So this is quite important one. I would think it is like it's really needed to support the migration, right? Because we don't, only one creator is not enough, right, for migration. So as I mentioned, migration just delete and create. The third API, this is the one mentioned in the paper, is evaluate placement. So what it does is it checks if the current microshard is optimal or suboptimal, right? So there are a few steps happens behind the API call. Is it checks if the migration is allowed, right? So what it does is like basically, for example, if we have another migration is happening for the same microshard, right? So it's in progress and we don't want to do that. Or this is second point actually. The first point, if it is allowed, means like permission check, right? So if we allow the data to be migrated. So there are a few steps. If it is allowed, then we're going to check if the migration is in progress. If not, and we just abort the operation or return some error status. And third one is determine the optimal placement. So this has the algorithm behind this determine optimal placement. They ran through the algorithm to have, based on the score mechanism, so they choose which new placement is better against the current one. So once it passed through all the steps and find a new placement, pass all the validation steps, and it started to migrate. So the migrate is, again, it calls into the database API to actually do the migration.
Is the evaluate placement API called by the client library?
Which one?
Evaluate placement.
Yeah. Yes. Actually, here is the one. I zoom in a little bit. You see there's the error between the client library and DPS, right? Basically, what it does is, if the application, I access the data and I found this access is pretty like high latency. I have a setting, a threshold of the latency, right? So once the latency is higher than the threshold I set, that the client library will call notify the DPS, say, okay, so currently the current micro shard I'm accessing is too slow, and please to run through all the steps to reevaluate the placement and move the data if needed. So this is basically what it happens. So to answer your question, yes, this call is initiated by the client side, asynchronizedly.
Okay, that's interesting. So it's actually driven by clients. What if there are multiple clients making the same call on the same microshard?
So here we have a few steps, right? So they run through the validation steps, right? So let's say we have more clients calling into this same DPS. If the first one, let's say if the first one calling into the valid placement and find a new placement which is better than current one, it started the migration, right? So the migration is actually a locking based solution. So if we have the following call comes into this function, and it probably will checks the second step will reject that already, because there is a migration in progress already. So it does not even reach the third step to determine the optimal placement.
It's something like.
Okay.
Go ahead.
Yeah, sorry. So what's confusing to me is it doesn't have an API call for the client to indicate that it wants to make the microshard stay in the current data center. It only has call to enable client ask for a migration. So what if the microshard is already, the access on that data is allowed already in this data center? Maybe it's even harder, or maybe it's not. Maybe it's in the same level. But what if other clients are asking about this microshard and it's already having access in the current data center? Will it be migrated out?
I'm assuming, actually this detail doesn't mention in the paper. I'm assuming there's a mechanism to, I would say if I'm the designer of this system, I probably do some intelligent way to determine if the data center is currently located in the current data center. But yeah, again, this is this is not mentioned in the paper, so I don't know what exactly they handled that case.
Okay, that's fine. Thank you.
I have one question regarding to evaluate placement. So, yeah, is in this process we are also gonna check the counters from other data centers, to calculate which one is the best placement.
Yes, yes. To answer to your question, yes. So I have I haven't reached the migration deep dive yet, but yes.
I see. Yeah, then why don't we have a centralized or something like a regional-wise service just for the evaluation?
For the DPS, I mean, you mean?
Yes, I mean, yeah, yeah, maybe not for other functions, but at least for this evaluation function, yeah, it makes sense to have a like a global DPS for all the data centers, maybe.
Yeah, actually, this is also one question I had when I read this paper. So along with other components, why they are choosing to put it as per data center level service. And so that's, yeah, this I asked this question as well to myself. So the decision they made to put this as data center level, I don't know, but to answer your question, I would say I probably would think about maybe putting this data placement service as the regional based will be a good idea. I don't know, because actually it's the query actually the need goes to different data center access DB. Right. So if from the following slides I would slides I would talk about how this guy DPS does the calculation. So actually it talks to other data centers as well to figure out the best one.
But does it matter? I mean, it needs to talk to every Akkio access DB anyway. Why does its own location matter? When you think about interaction between the client library and the data placement service, we want to optimize this path, right? So it makes sense to place DPS in every data center. But for the DPS itself, wherever it is, it needs to talk to every SSDB to get the global information anyway.
Yeah,
That's my understanding.
Yeah, the thing is something like it's more like my concern is every data placement service could make maybe the best decision for its own region or for its own data. So I mean, this decision needs some global states. And for example, if two data centers, they are both sending some evaluation requests to their own DPS service, and maybe they are come up with different results because of the data in the consistency issue, and maybe they are competing for the resource. That's some failure scenario I'm thinking about, but I'm not so sure if that's true, or they have some other mechanisms to ensure that they have a better consistency guarantee, so that will not happen. I'm not so sure on that part. So I'm just raising some concern. I think the placement calculation should be something global. And if they are doing it in a regional like scope, maybe it makes more sense. I'm not so sure.
I just want to ask something. So we're talking about the global thing. So just wondering what if they put it into a global data center and that the crash, what's going to happen? How could you actually hand over those kind of failure? Because you already say like you wanted the data like pretty much centralized.
Yeah, probably I would suggest probably we could deep dive into the steps how the calculation is done, and then after that, we probably will have another thought on this problem, how, if you are the designer, how you improve that. Does that sounds good? So we can move on next to, yeah, the next one I would talk about how the optimal replacement will determine. So after that, probably we have like another thought and better understanding.
Yeah, sure. Let's move on.
Okay. This is the, actually, by the way, I'm not following the order from the paper itself. So I just try step by step and have a better presenting to let you guys know what is actually happening. So let's say we have 3 data centers, right? DC1, DC2, and DC3, right? So we have, based on our knowledge from the paper, we have access service per data center, right? DPS per data center, right? Also, I didn't add the location one, but there will be another one, location one. For example, currently we have a microshard X. I just call it X. All right, it is mapping to the location handle A, right? So this is basically just the indicator of where data is, right? So the data one replica is here. Let's say, okay, in data center 1, and another one, the replicated data is in data center 2. So let's say, yeah, that is the base case. Let's see how it does from the Facebook to from DPS to decide which one is the best. Okay, so can I just type in something? Okay. Okay, so for example here, right? So the first thing I want the DPS want to do is to count, right? It counts the number of the access, right? To count the frequency basically of let's say just microshard X, right? So this is the thing it want to do first. And how it does that is, let's, for example, currently today, we have user across 3 different data centers, right? So for DC1, I got maybe 100 requests. I would just make up the number. It's not a real number. From data center 2, I got 0 access. So the access means access to the data microshard X, okay? So, and from the data center 3, I have 800, for example. So currently, we can see that this is a valid use case that the microshard is actually located in the data center A and data center 2, data center 1 and data center 2, right? But not from data center C. So I don't for user from access the data microshard X from data center 3, they will have the latency, right? So this is the actually valid use case. What happens next is, right? So we do some calculation based on the location handler, right? Handle A and handle, and we have other location handle B is for other data, right? So across all the data centers, right? So now we have a location handle A, right? So this actually is handling all the replica of microshard X, location handle A, and we do the count, right? So for location handle A across 2 data centers, 1 and 2, we have how many? 100 in total, right here, because data center 1 and data center 2, add them together is 100, right? So for location handle B, right? So assuming, right? So assuming if we are going to have the microshard X migrated to location handle B, let these two guys to handle my data, right? So basically assuming we are moving data, removing the replica from data center 1 and put it into data center 3 and have it assigned to a new location handle, you can think that this is the new identity of the replicated data, right? So if we put the data to these two guys, of course, data center 2 and data center 3, so we will have this count for 800, right? So this is based on the assumption. If it's not real, but it doesn't happen, it's just assuming, right? So now we can see two scores. One is 100. The second one, the location handle B is 800, right? So in this case, we have the winner, right? So the winner is location handle B, which means currently we have location handle A with lower score is not optimal, right? So let me back to the map here, the diagram here. As you can see here, actually in the location DB, we are mapping the microshard to location handle, right? So now we found this guy, in our case, the microshard X currently mapping to location handle A is not optimal. We got a winner, then I need to do the migrate. So this is the one case. So how they calculate that. So why we want to get this one, because location handle actually indicates the location of the data, right? So in our goal is just to find the location handle, right? Now, what happens if there is a tie? Okay, if the two scores are the same, let me move back to like 100, right? Those are 100. So we don't find the winner. So what happened now is we want to do another calculation, right? So this calculation is also the same thing as what we did at step number 1, but it's not based on the count anymore. It's based on another score mechanism. They count the like CPU usage, right? So there will be another per data center scoring, right? Based on CPU and the memory, like local storage. I'll just put it storage, right? So after this step, we will also have a new score for different data centers based on the algorithm, right? So now we probably have another score for data center. Let's say we have this guy, it's 1000, right? The higher score, we find the winner, right? So again, this is a map to the handler as well, right? So the same thing, but they are based on different metrics to do the calculation. So in our case, this is handler A is still 100, right? So handler B is now 1000. Right. So this is how the DPS does the calculation based on the access pattern, and if there's a tie, based on the data center score, based on the CPU memory storage, right? And I calculate that for different handlers. Now I find the winner. The winner is B. So which means my data is not optimal. I want to move it to from this location handle A to location handle B. So eventually there will be a data migration across data centers. Right. So if there is another, in worst case scenario, if this is another tie, right? So we cannot find the winner. So what the Akkio does is just a random pick one, randomly pick one. Okay, so this is how they do all the calculation, all the steps. And actually, when I read the paper, I had the question, like we are looking for the candidates, right? The candidates is the location handle, right? The location handle from different data centers. We have different, we have data center A, B here in our diagram. So how can I get those two? This is what question I had when I read the paper, and eventually I found it is actually this thing, location handle, is fetched from another service. Is not mentioned. It's just one sentence mentioned in this paper. Is Facebook's own configuration service. Let me go to the diagram here. The red box on the right side corner, right? So this is the one. This is the one holding all the configuration metadata and how many like handlers we have, data handler, replication handler we in within each data center. So this is the one how the DPS gets the replication handle A and replication handle B. Okay. Any questions so far? Okay, good. Let's move on to the next one. So we know how DPS does the calculation to find the optimal placement. The next thing is what happens next if we found the optimal placement, right? So we want create a micro shard, right? So create a new micro shard and move the micro shard is to the new place is basically the similar idea. So I could have it covered in the same place. So for a new micro shard, let's say if I have new application data, which is written by the client, it doesn't exist, right? So the first step for the application service is going to, I would say maybe I generate the message in the structured way and assign a micro shard ID to it, to the new data, right? So next one is a call to the location service, because for application itself, it does not know whether the micro shard exists or not, right? So the first call for application is calling to the location database, right? Based on this API get location micro shard ID, which is a new ID I assigned to this new data, right? So we could not find anything from the location DB. The first one hit the cache and cache miss and hit on the database, and I couldn't find anything. Right now, the application DB return, it could be error code or any other messages back to the client. But in the case of the Akkio, in the paper it mentioned it returns a status unknown to the client side. So which indicates that the data is not present. I don't know where the data is. So if you want to write the data, you write to a new place. So what happened next is the Akkio client library. It will call to the DPS. Remember, we have two APIs, right? Two APIs mentioned in the paper. That's not one delete. I didn't put it here. There we have an API from DPS. It's create microshard, right? So once we got an ON back, and I have the microshard ID, I have the data. I call this one create microshard for me by passing in my microshard ID, right? So the DPS then it will go through like all the steps to decide. So in the paper it doesn't mention anything about what behind this API call, but from my understanding is actually DPS is doing another calculation, right? The same steps we talked about earlier, to pick the best place where to put the data, right? Once we find, I call this function, I find the good place where to put the data. So what happened next is, right? So actually there's another thing probably I'm guessing behind this function call is to choose the closest data store server. Once I decide I want to put data to location handle A in our previous case, right? So let me get back to, I want to put the data to location handle A. So I'm guessing this is just from my understanding, it will choose the primary, and write the data, or if the underlayer data store is not using the leader-based solution, probably it would choose, if you're using leaderless, right? So it could choose the one which is closer to the client which trying to access write the data. So this is from my understanding, not mentioned in the paper. Okay, so once we get this one, DPS actually we'll call the let me recall if DPS is calling database or the client will call the database. Okay, so what happens is, like, once I create the microshard function returns, it returns a location handle back to the client, right? So it's not the DPS writing the data, the application data to the data store. Actually, it just returns the location handle, right? So I found one for you, and which is the closest to you, and it passed back to you. And the client, because we have the data store client library, can read and write data, right, to access to the database. So I get the handler, I write the data into the database, the view state ZPDB data store. So this is not done yet, right? Because we have a new data written into the data store, and we also want to update this guy. So the DPS will call the location, we call the location service to update the record for me. We have the microshard ID, and we also have the locations at this point, right? So it's easy to update location service. So what it didn't mention in the paper was, because there are two channels. So one channel is client writing the data to the data store. Another channel is this one, DPS updating the location DB. So these two channels will cause some like data inconsistency issues. So let's say if I updated the location DB first, but my data is not yet ready in the data store, So what happens is the next access reader request will have the records. Okay, the data is supposed to be ready under location handle A, but actually when I access to that, the data is not ready. So if you guys on the call recall, if Facebook the Akkio system handles this, but I didn't remember they mentioned how they solved this problem with details. Yeah, this is just one problem I realized when I read the paper. Okay, do we have any questions so far? Okay, let's move on. So this is the core part. This is the most important part during this whole process, right? So it's a microshard need to be migrated if we found a suboptimal placement, right? Based on our previous calculation and the sync call notify the DPS to do that for us. There are two. I put this screenshot on two sides. These are the example from the paper. So on the left side is because this paper is really okay, coupled with ZPDB use case. So this is the one for ZPDB case. The other one is for Cassandra case. Personally, I think those two solution steps have both pros and cons. I don't think they are very the best solution. So I would step by step to introduce what happens, and maybe we can have a discussion on this. Okay, so by looking at these two steps, two screenshots here, the high level steps for both solution. So what they do is the first lock, right, and to migrate data in the middle. And once the migration is done, I unlock. So the lock here means I do not lock a read or write, right? I just lock the migration. So I allow user to read and write the data, but I do not allow another migration happen at the same time, right? If I have another one in progress. So let's see this one, the left one first. Okay, so after I lock, so from the paper it says it sets the source environment. I would say like source location. This is a data store, right? So ZPDB, I set the source for the microshard. The ACL is access control list to read only. Right. I do not want any updates to this particular microshard during the migration. Right. I set to read only first, and then I read the microshard from, because this part is doing the data movement, right? So I read from the old place and update right to the new place, right to the destination. So this part is also a atomically call, right? So this is pretty straightforward. We don't want any concurrent write happen. So once the data is written to the destination, I set the microshard ACL to read only. So this one, at this point, okay, we have source and destination both under read-only mode. So no one can update the data during this period. Okay, so at this point we have data ready in two places. One is the old one, and one copy is in the new places, but both under under the read-only mode. Okay, so next part is going to update the location database, right? Because we want to, data is migrated at this point. I want to update the location DB to reflect the new place, new location DB updated, which means all the access will be served by the new place because the location has been changed. Right. So now if everything goes fine, I can just simply delete the source and ACL. ACL is for the source environment. Right. And now I'm going to set a destination ACL to read and write and unlock. So for this one, I see several, like some problems here. Is the first problem I saw is this guy, DCL, to read and write, read only. So at some point, so my application cannot update. Right. So this is the first place I don't think I like this solution, but this is how it was designed from the paper for ZPDB case. Right. So this is the one. Another thing I want to mention is another point I don't think I quite like it is because for the ACL way is what happens if the migration crashes during the migrate. Right. So if my migration crash in the middle anywhere, so it will cause the application this particular micro shard to be only read only. Right. So because this is the for database, access control list is for database, is using the ZPDB, it's a setting for the ZPDB. If a migration is crashed and I need to restart the service, takes some time, right? So it takes some time in between. My application is only read only. It cannot serve in any write requests. So this is the second point I don't quite like the solution. And once after that I read another example for Considra, and it solved the problem for this read-only cases pretty good, but it also has some other problem. So any questions so far for the ZPDB case?
Just wondering, it seems like the ZPDB is based on the RockDB, right? And the RockDB is like based on the log structure, like LSM tree, which means like append only. And that's why there's no updating at all. It's just like keep appending. That's my understanding.
Okay, so what I mean is it's okay to be the read only.
Yeah. So by what I currently see is like ZPDB is based on the RocksDB, and RocksDB is like a log structure database. Basically, just like using very similar to like a Cassandra, and which basically means you only allow the appending logs, like logs append only mode, and yeah, that's why like maybe they can do this kind of thing, because you will very like rare to say like write some do some update.
Okay, so yeah, I'm not the expert of the ZPDB, so I don't know how exactly the ACL is implemented within ZPDB. So if what you're saying is even I set the ACL to be read only, I still can write to append to the log, right?
Yeah.
So if that is the case, then okay, so then what does this ACL read only blocks? I don't know. Probably yeah. We have another session in the future to talk about RockDB. It's coming next week or is the week after next. So probably people can deep dive into that part later. Okay, so on the right side, let me move it closer. So the implement two solutions, one is for ZPD, and they realize they have a use case for Cassandra, so they have another use case implementation for Cassandra based. So what they said is the Cassandra version mentioned in the paper they're using does not support ACL, but I forgot it's like open source version. They mentioned it does, so that's why they have a separate case for Cassandra, because the Cassandra version they are using does not have the ACL, so they have a different solution. So on the right side, the same idea. I just lock the migration, right? But does not lock the read and write. So what happened next is I start double writing to both source and destination. So these steps actually is a location DB record updates, right? Because I want to write data. If I have a write request, I need to redirect to both source and destination. So if you recall what location DB does, it tracks the location of the microshard. So this step is a call to the location DB, right? So it at this point, so this is another one I want to highlight. It mentioned in the paper why they are inserting this step in between to wait the cache TTL to expire. Let's skip this step. It doesn't hurt the whole steps for now. I will just come back to talk about this later. So it's the main purpose is just for make sure the cache consistency between data store and the cache layer. Let's move on. The next step is going to copy data from source to destination, right? So the copy is, so mentioned in the paper, the data is actually the timestamp based, right? So I'm currently copy the data from source to destination. It's pretty straightforward way, right? This is a migrating. And once the data is really like migrated, right, I'm going to switch the reading request to destination. So at this point, right, so all the writes are redirects to both source and destination. But there's one thing it's not mentioned in the steps here is how about reading, right? Reading is actually before this step, before switching the reading, before this step, the reading is still redirected to the source, right? So before that, now all the updates to the data, microshard, are right to both places. Reading is served by the source. Okay, now I'm going to copy the data from the source to destination. So this step, the data I'm copying, again, I just mentioned Cassandra is a solution that uses timestamp based. So I'm going to copy the data before the starting time of this double writing. Right. So let me put an example. Right. So I'm at the start double writing step. Okay. Now, before that step, I still have. Let's do this. I have a full bar, right? Value 1, bar, value 2, right? So after this step, start double writing, if I have writes to these two data p-value pairs, they are both be redirected to source and the destination. Forgive me about the typo. Okay, so this is basically what happens after the start double writing, right? And we said we skip this step, but before copying data, I would want to mention is like this is the write, right? So we still have a read requests. Read request, if I read full, actually this one is redirected source. So this is clear, right? Just put it this way and easier to see it. Okay, so now we are copying data. So in the paper, it mentioned that the copying the data actually is copying the data happened before starting double writing, right? Because we are good for the data after the double writing, since they are writing to both places. But for the old data, it's still in the source, but not present in the destination. So what happens for copy is actually copy the, I would just say older data, right? So this is what this copy means here in this step. So once I got these three dot lines copied to the new destination, what happens is I could safely switch reading to the destination because two places, source and destination, are having the same data already. Okay. There's one case could happen in between during the copying, right? Is conflict. Right. So let's say if this one is something, I'll call it full, right? Value 2. Right. So now actually double writing started. I'm updating this full to value 1 from value 2. And copy the data, because this is all across a network, right? Because while doing the copying, we cannot guarantee this guy is written in prior to the copy, right? So what happens is we could find the copy of the full value 2 could happen after the full value 1, right? So in this case, it's like the data copying is pretty slow, and we have the value 1 returned to the destination, and now the copy is actually updating data back to value 2. So this is a conflict. So in the paper, what it mentioned again, the timestamp is timestamp. I would say 3 times. It's like pretty important. They are using the timestamp to guarantee the. I will use the phrase like last right wing. Right. So because they have a different timestamps. For value 2, I would say I'll just put 1 here. I'll timestamp 1. For value 1, we have 2. Right. So if 1 comes later than 2, it's less than 2, which means it's happened before. So I just ignore this guy.
So when you copy data from source to destination, what does the copy mean? Is it replaying the log of operations, or we just write to destination using the value in the source? What does it mean specifically?
It's not mentioned in the paper actually. So for the paper itself, it mentioned something about how the data is really migrated and copied over from one place to another place is really database dependent. Different database probably have different behavior. To your question, I would think if I prefer to interpret as the second way to replay the log. That is, yeah, because for the database that we are writing to the data store, actually we are just like Alan just mentioned, we are actually just append the log, right?
Yeah, I mean, if it's just replaying the logs, then it doesn't matter which operation arrives firstly, right? You can just use the timestamp as a criteria to apply all those operations in order.
Yeah, that's true.
We don't really need the last right wing. We just need to apply those operations according to the timestamp, and the correct result we'll get the correct result by the end, right? Or you are saying they're just looking at the right with the largest timestamp or something like that, then use that directly without applying previous operations.
Yeah, I think this is a good point to do the follow-up. This case is really based on the Cassandra. I only know Cassandra is it Cassandra a database implementation based on replaying the log for that part? Yeah, probably the best way is I will probably do the follow-up on this. So I'm not guessing any true or false answers to make you guys confused. So for this part, what Fabian said is correct. If you are just replaying the log, it doesn't really matter because the log is a append only, right? So it's already data stamped, sorted, right? So if the implementation of the database is just, it's a really just copy the data itself, right? So one column, right? Per column based. If I copy this row, entire row, and write into the new row, probably it will have this problem. So this is a conflict issue is also mentioned in the paper. So I'm assuming probably Cassandra is not. Okay, I'm not guessing here. I'll do the follow up where we can get this answered for our future sessions. Okay, cool. So this is where am I? Copying data. Okay. So after we copy the data from the source to destination. So which means we now have the same data, right, from both source and destination. So it's okay. Now we just switch the reading request from source to destination, right? Before these steps, reading is from the source because the destination does not have all the data yet. Now we are going to switch the reading request. So what happens now is I will switch like read to destination as well. So I just copy this guy here. So the only difference is now. Okay, now we are, switching from source to destination. Okay, but at this point, the write is still writing to the two places. It's okay, right? Because as long as we're writing data to the destination, it's okay, right? So the following step is we're going to write to the destination. to end the double writing. Right, so now all the new data will become both read and write are going to the destination place location. Right. So after that, if everything goes smoothly, I just removed the data from the source. So now everything is to the new place. Okay. So once everything is done, unlock. So if the data is suboptimal, we can do the migration again. Right. So this solution has a few points, a few steps we just ignored. So this one, the wait for location information cache TTL to expire. So in the paper, it also mentioned that this could be improved because the waiting is really, really expensive operation, especially for the case of Facebook, right? So the TTL, even it's short enough, but still too long for the application, right? So in the paper, it mentioned that the only purpose of these steps, why it want to like wait for the cache TTL, is because they do not want the location info, the cache layer has stale data, right? So if the TTL is reached, expired, the stale data will be evicted, right? So in that case, even cache miss, we still can get the data from database to guarantee the data consistency. So the paper mentioned that this can be done by the writing invalidate cache. So what does it mean is like I write to the database. So like the double writing here, I write the full value 1 to the database, to the data store. And after this call, I'm going to invalidate the full key from the cache. Right. So this will solve the problem of the waiting. Right. Or if we're using the write through cache, that means we write to if we recall the write through caches, we have let me write at the bottom. Okay, so we have client, we have cache, we have data store, right? So the write invalidate is I'm going to write to the data store, and then I'm going to invalidate the key for in our example with the full, right? So in this case, the cache will miss next time, but the data is consistent. Or write through cache, right? So write through cache is exactly like what we had here, right? So the both places will be updated on right. So this is this is one thing this is one thing I interpreted from the paper, what they mentioned about the writing rather than write through. Okay, so this is the whole flow. Let me move things back. And so the lesson we learned, actually, at least I learned from this migration flow was the first thing is I want to lock using lock mechanism to handle the read-write problem. Like I do not want multiple migration happen at the same time for a particular microshard. So I'm using the lock mechanism. So another lesson I learned from the paper is about the fascinating thing is about double writing. Right, so you see this guy on the left side, ZPDB, the example, they do not use they do not use the double writing. Right, if we use the double writing, which means the read-only case can be nicely handled. Right, so this is a second lesson I learned from the whole path. So another lesson I learned is the actual data migration need to be atomic, right? So which means, so like this part in the middle. So we do not want a partial failure. So any write to the data store need to be atomic. So this is the lesson, third lesson I learned. So another one I want to point out is I'm not sure if you guys see this interesting thing, the order of switch reading and writing, right? It has to be reading, switch reading to destination need to be happen first. Right, I'll pause 3 seconds. So for the question, why we need this order. So it cannot be the switch writing to destination and then I do switch reading. 1, 2, 3. Okay. So the reason why that is because we want to make sure the data consistency. Right. So why that?
I don't think I understand.
Okay, so the things is, so what happens if the migration crashed in between, right? So it could happen here, right? So if we switch the writing to the destination, right? So the data is actually written, it will be written to the new destination, right? But something happened here, it crashed. We haven't got a chance to update the reading. So the reading is still from the source environment.
Okay, that makes sense.
Right. So this is really important. It's for the failure handling. So if anything happens in between, so we have to do this. So this is one point I want to highlight. Another thing is about also the one I talk about is the around the cache TTL. We could use the write invalidate or write through cache. Just get rid of the waiting. It's too expensive. Okay. So the last topic I want to cover today is about how DPS handle the failure. So why I only pick this one because let me go back here. So for failure handling, these two guys from the paper, they said the data is persistent, right, in the database. So if the service, so actually the service in front of the data location DB layer is just stateless, right? So if anything crashed, they can just restart it, right? So if the data store one node is down, so the HA, the fault tolerance is handled by the data store. So it's okay. This guy fails as long as if you don't lose all the data nodes, then. So this is handled by the location database ZPDB layer, and all the service layer is it's a stateless, right? So the same thing happens here as well. So it's pretty easy. if anything happens against these two components, we just restart. But the thing I want to highlight is this one is really, really like important because it can like crash in the middle of the migration. So that's why I want to put this one. It's also the one pretty highlighted in the paper. So how they handle that is from the paper. Interesting that back in 2018, Facebook is still using Zookeeper. So the idea is they have the global Zookeeper, right, to keep tracking the DPS instances, right? So it also assign a increasing only sequence number. This is just the ID to each DPS instance, right? So I put an example here, right? Since the DPS is a data center level, like we have a data center 1, and the instance has to be running against some server, right? So this is the server 1, right? So this is the DPS number 1. The number 1 is assigned by the Zookeeper, right? This guy is alive. So Zookeeper is tracking the status. And we have another one in different data center, right? Data center 2, server 2, DPS 2, since it's a data center level. Okay, so this is just my guess. It's not mentioned in the paper, yeah, because there should be someone tracking the status of those instances. So since they're using Zookeeper, so I'm assuming Zookeeper is the one have those records stored somewhere. Okay. So what happened next is like if I found the DPS1, so the application notify the DPS, say, okay, the current micro shard need to be replaced, need to be placed to a new place. And the DPS1 said yes, and go through all the steps, find a new place, and start a migration. And the migration status is, so this is an interesting place. It's also mentioned in the paper that actually the migration status is kept in the location database. All right, so what it does, it means that, what does it mean? It's DPS1. I'm currently migrate the micro shard 1 to a new place, and the status is started. Right, so this guy is in the location DB. If something bad happens, the DPS1 instance, this one, data center 1, server 1, DPS1 crashed. It's gone. And then the global Zookeeper, there's a way I'm not sure if it's a heartbeat. It could be a heartbeat between Zookeeper and those instances, and it detects the non-responsive status from this DPS1, right? So assuming we had a 2, right? So currently the other one is still okay. It's still alive. So what happened next is like we need to recover DPS, right? So a new DPS will be started. So some like orchestration platform handling the service restart, right? Based on the configurations, right? So a new service DPS will be started, and the global Zookeeper records will be updated. So for example, here now, because data center, so data center 1 DPS1 fails, and a new one comes up within data center 1, but probably it would be assigned to a different server, right? It was one before, but now it could be on a different server. Now this record updated. So number 3 is assigned because Zookeeper is assigned a increasing only sequence number to instances. right? So now we know which one is replacing which one, right? Within the same data center, but two different services, servers are fine. And 3 is replacing number 1 because 1 is non-responsive and 3 is alive currently. They are both in the data center 1, and DPS is the data center level service, right? So we easily can know this one is replacing DPS 1. So what happens next is describing the paper was the DPS 3 will query the location DB to update the migration status. Remember, we had a migration status here stored in the location DB. Right, so this guy is, since the migration crashed, right, from, the DPS crashed, so no one tracks these records and no one updates that. So now the new DPS need to update the records. Right, it was DPS 1, microshard 1 started, so it needs to be updated to DPS 3 from 1. Right, because we know that 3 is replacing 1. Right, so this is my guess. It could be, so these two words are mentioned in the paper. So it said the migration either to be resumed from last points or to be restarted. So they didn't, the paper doesn't elaborate all the details on how it's done by the Akkio system. But this is my guess. So now we have this status, DPS 3, right? So it really depends on the migration path, right? Which way we want to choose. So if the migration is idempotent, probably we can just restart that. So if not, if we just want to resuming the migration, it's really up to the data store how to remember which steps I just did, and now I need to resume from that step. So this thing is not mentioned in the paper. So I just put a summary here. So DPS 3 comes up, it either restarts or resumes the migration again. Yeah, I think this is the end of the slides. And any questions so far?